Next, I will explain the ray tracing and abbreviation. This is when you need to design the optical measurements. Sometimes you may use this kind of technique, and even if you don't use it, maybe it's good to know how the people working on optics is using those kind of techniques. So one is called ray tracing. So as you could see, by using the Snell's law, and if you think about one of the light, portion of the light, and you can every time reflected and refracted, bent, and follow the in a homogeneous medium, it's just go straight. So you can follow the light path. So like this, you can think about many different type of the light path, and then how these lights are going around, which is called ray tracing. And there are many nice ray tracing software to design the optics. So what I shown here is, in this case, there is some problems often encountered when you build optics, which is abbreviation. This is a focus error due to many reasons. Actually, I show here only 2 reasons, but there are many other abbreviation reasons, which means focus error. So as I show here, the lens must focus down to the focus position, but especially it can be, it is usually when you use the light, using the center of the lens, mostly light is focused down to the focus position. However, if you use a light, very big one, and the light pass around the edge of the lens, it's focused down to the somewhere a different position, which is due to the curvature, so the design of the curvature of the lens. And another reason for this focus error is due to the color. So depending on the color, the refractive index of lenses, of course, usually made of glass, mostly. So glass has the wavelength dependence of the refractive index. So depending on the wavelength, meaning color, the bending angle is different. That's why there's some color abbreviation. So depending on the color, the focus position is sometimes different.